I'll talk about this concept of distributed training of AI models. So, one thing, it's very clear that training AI models is quite expensive, and not everyone can afford to have their own data centers or even rent their own data centers. So there is a uh, there is a different way suggested for training AI models, which is by using distributed systems. So where the processors will be situated all over the world. But even this system has some drawbacks. So the first one is the slow internet speed. So when training is done within a same data center, so the communication speed between the GPUs is quite fast. So as per the source that I referred to, it says that uh, the communication speed between GPUs is about 1.8 terabytes per second. But when you start training in a distributed system, so the power of the speed of internet is exponentially slower as compared to the communication speed between GPUs. So it is said that it is at least 1,000 times slower than that, and the range is between 1,000 to 100,000 times slower. So the speed is a very major drawback here. The other thing is synchronization. The problem of synchronization. So since communication over the internet is an asynchronous process, so training updates, the updates that has to be made between the different processors will be asynchronous. So that is another kind of a challenge while using distributed systems. So uh, reducing these kind of drawbacks are some of the challenges in distributed training. So about the challenges, we can't do much about internet speed. It is what it is. For at least for the person who is using the AI, who is using the AI training model, who is trying to train the model, they are not working on the internet technology, so they can't do much about increasing the speed of the internet. But what they can do is try to determine or try to figure out how to send as less as data possible throughout this training process through the internet. So that's the one thing that they can focus on. The internet speed, they can't do much about it. So below, next I'll discuss three research by three different teams. Each of them have proposed different solutions to these problems. The first one is a solution called PTELS, which is developed by a team of researchers at Yandex. So Yandex is a Russian company. You can think of it as the equivalent of Google at Russia. So that's what PTELS Yandex is. So what they propose is that that different hosts will be hosting a different layer of a training model. So each device will be scattered throughout the world, and each device will train a single layer of the model. So by layer, they have mentioned as a transformer layer. So each model will train a transformer layer. And when that once the training of a single layer is completed, all the weights and biases or all the parameters are passed on to the different layer, to the next layer. But unlike a model that is trained locally, since the next layer is in a completely different computer, so this transfer of this data has to be done through the internet. So the data has to be transported to be so that it can be transported across the internet. But here's the main problem here: that compressing data during training can interfere with the training process because by compressing, there could be some loss of data, and we need actually a very precise data, precise values of the weights and biases for the training process to be efficient. So that's a big drawback of this method proposed by the Yandex, the team at Yandex. Compression is the one of the biggest drawbacks of this model. So the next solution is named as distributed low communication, which is developed by a team from DeepMind, and it was, I think, so released into September 2024. This framework. So they use a concept called federated averaging. So what they do is that different different components, which they refer to as workers, different GPUs in the whole of the distributed system. Each GPU is called as a worker here. So each worker trains the model for a few times, and then they after and after a periodic after some time, so periodically they sing their weights and updates. So but the thing is that each and every worker has to be powerful enough to hold the whole model, the whole data, and have the both the memory and the processing power to hold and run the whole model. The only difference is that they don't have to. The only advantage here is that it provides parallelization, which means that they don't have to suppose instead of going through 1,000 runs of training by a single worker. If there are 10 workers, each will go through 100 rounds of training, and it will be divided parallelly. So that's the only benefit that is being provided here. Apart from that, another benefit is that the amount of communication is also minimized there, because now they are not communicating after each training layer. They're only periodically communicating to to sync the weights. So, so these are the two actual advantages, which is that it provides parallelization. So each processor doesn't have to work for a high period of time. And the second is that it minimizes communication. But again, the drawback says that each worker GPU has to be very powerful in and of itself, because it must have the capability to both hold the model as well as to run the whole model, because it's running the whole model at a time. So the next one the next concept is the concept called decoupled momentum optimization. Now this was developed by a team from NOS Research. It is pronounced as it is spelled as NOUS, NOS Research. So what they've suggested is that instead of syncing the entire model periodically, so what if we just focus on sharing only the fast-moving parts of the optimizer momentum? So what is optimizer momentum here? So optimizer is the thing that adjusts the model's parameter. So you can think of it as the gradient descent, which optimizes the model's parameters. So what it says is that not all at each round of training, not all gradients contribute to the final solution, because suppose there is suppose you're trying to fit a linear regression as a line to a data, a linear regression model. So there could be some data which is outlier, which is very far above or far below. So in the training phase where they are trying to fit the outlier data into the whole model, so the the line will tilt a bit above just to fit that model. But as further examples are added there, so the overall that outlier will become insignificant because it will try to overall fit the other data which more fits the pattern. So that goes outside the proper direction of the actual final data or the final model. So there is some kind of noise. Every now and then there will be such kind of noise. So what if we try to what's the point of trying to sync all those kind of noise data, the updates that are being made because of those noise data? So the idea is to ignore those data. So that is what they're doing. That's the idea behind this. So so I haven't looked at the technical details, but what they've said is that they use concepts from signal processing to decouple the momentum from the optimization process, and so and then they separate them into slow and fast moving components. So the slow moving components capture the long-term gradual updates, which do not need to be shared frequently. But so they do not share those kind of things during the sync process. So this model only focuses on sharing the fast-moving components, which are smaller and more compact. Instead of so they only sync those kind of updates instead of synchronizing the whole model. So yes, that's the main idea behind it. And the idea, so the concept is that they will only share the fast moving components, and the slow moving components can be computed locally by the respective processors of that model. So in the end, what happens is that it drastically reduces the amount of data that needs to be communicated between the workers. By workers, again, I mean the individual GPUs in the whole network. So it makes the whole process a lot more efficient and bandwidth friendly. So that's the idea here. Because as I've initially mentioned, you can't change the speed of the internet, but all you can do is try to come up with efficient techniques to minimize the amount of data that you are trying to transfer between these the each and every node in the network. So this one, so here's the idea behind this. These are the 3 different papers or research, and they have come up with different ideas to optimize how they can send as less data as possible to optimize the training process. So this is my yeah.
So then distributed training, then fundamentally it's basically using cloud, right? Meaning
Yes,
it can be called cloud.
Yes, but
so are these services provided by Amazon, AWS and stuff?
No, I think so. The whole point of this is that they are not using some established players' hardware. It's using people's or some. That one of the examples mentioned here is that it's like cryptocurrency but for AI. It's like distributed computing for AI, where each and every in in blockchain, each and every node has a copy of the ledger, and each and every node computes that thing. So they're using this. Means the idea came from there, or you can
But
think
that
that idea comes
requires a
from
data
there.
center ultimately. If
No,
you
I mean by cloud computing, if you mean a data center, I don't think so. They're trying to say that thing, that it doesn't. It's not using a data center in that sense. I don't
mean,
think distributed
ultimately it
compute.
has to be trained in GPUs, which has to be in bulk, a lot of them. So
That's what they're trying to do.
their reason of coming up with distributed training is because it's too expensive for everyone or anyone who wants to train AI models to have their own data center.
Yes, means
Right.
well, we're trying to. Yes, like only established players like Google or OpenAI. Those are the kind of people they have the financial resources for those hardware.
Yeah.
Now, they have given some examples here too. I forgot the names of the companies there. So, wait a minute. Let me see. I have the website open. Can you see this one?
Not yet.
Can you see this page?
No.
Now, can you see?
Not yet. Still can't see.
Now,
No. No, I can't even see. I can see the screen. I don't think I can see you also.
okay.
Yes, let it be. I think you can just tell what it is.
Okay. So, can you even see me or even I'm invisible now?
No, I cannot see you also.
Can't see me.
Uh,
Then let me change my internet connection.
I think I can see you now, and the screen also.
Okay. Okay. Now, this is Intellect One. It is the world's first decentralized training of a 10 billion parameter model, enabling anyone to contribute, compute, and participate. So, the model.
So Intellect One is the name of the model.
Yes,
Okay.
it's on the Llama chart. You can see all of the contributors. They are named here.
So they have contributed their hardware for training.
Yes. So this is the idea that they're trying to say. It's decentralized, not a centralized data center like a Google's G or an AWS or a GCP or an Azure.
Mhm.
So it's more like community supported endeavor. That's the point they're trying to say here.
So is Hugging Face also providing it or what? Because I see that logo.
Maybe a little bit of them, some of it. How to rotate this thing. Yeah, that means this is the idea behind it.
Yeah, understood.
I think so. My wording was wrong. I I did say cloud computing, but yeah, cloud actually means data centers.
Mhm.
It doesn't. So anything else you want to say about this?
No, nothing from me.
Okay, then you can talk about your topic now.
Yeah. So I found one problem statement in Replit bounties. So it's quite a old what should I say, a bounty. It's not new. And this application, like it's at this point, it has been done many times. So the problem statement simply is you have Slack. It is a work-related chatting platform. Like you may have heard of Slack before, right? Or have you not?
Yes, I have used it. I have used Slack.
Yeah. So So what there's the problem statement is that Slack will be the Slack is being used in a company for company communications. So the LLM will be trained on this company detail, and the user can then ask. There will be a chatbot within Slack, and the user can ask questions. It can ask it questions that are related to the company, and the LLM will fetch the information in real time using RAG. So that is the higher level problem statement. And the user interface in this case is going to be Slack. And the problem statement defines the data infrastructure. It says to use Databricks for data processing. Databricks, I think, is a service provided by Amazon AWS and Amazon S3 for data storage. So the AI ML components is going to be some LLM and RAG. RAG it stands for retrieval augmented generation. And so the cloud infrastructure is going to be AWS, right? So the main workflow basically is something like this. So the user will ask a question in Slack to the chatbot, or yeah, to the chatbot. The question will go to AWS via some APIs and stuff. And then in within AWS, the Databricks and S3 will do the data processing and use the LLM to give out a reply, basically. So at a very high level, that is what is the requirement or the problem statement. But as I just want to implement this for learning purposes, it's better to go for open source alternatives, because Slack, I don't think you can, maybe it's not possible to create chatbots if it's a free tier. And many of the cloud infrastructure they have mentioned here, like Databricks and S3, also has limitations in free tiers. And initially, the problem statements also mentions using GPT-4 or GPT-based LLM, which also requires to be paid to pay for their API. So some open source alternative can be used. So for GPT, we can replace with any open source LLM like a Llama, and Databricks and S3, which is used for data pre-processing and data storage. It can be you can use PostgreSQL on our local machine, and I think that will be in terms of learning, that will be better, because you will have more idea behind what is going on behind the scenes with the data. And instead of using Slack, we can just use either Discord for the chatbot, or we can even create a simple like a web interface using Flask or some kind of other frameworks. So yeah, so far this is the overall problem statement I have understood. I have yet to implement it, so that is all really.
So you're planning to implement this whole app application.
Yeah, just for learning how things work in Drag and all.
So have you done anything related to RAG earlier?
No,
No, even I haven't done it.
yeah.
So have you worked with LangChain or those kind of things?
And I have not used any of this before. This will be my first time.
When I've tried to, I've built simple chatbots or some kind of things by using Claude API, because ChatGPT's API requires credit card. Claude's doesn't require. So I used Claude's API.
Yeah, but you can use other open source, right, which doesn't require anything. We have Llama or Mistral
Yes.
and many
So
others. Even I think DeepSeek, something, it's a new model came out like few weeks ago. DeepSeek version 3, that is also open source. You can use
yes,
one of them.
I've used some models from Hugging Face through their API and through using
Yeah.
LangChain as well. But yeah. So DeepSeek, I think so. It It is available at LangChain, so it should be. Oh, sorry, not sorry, LangChain in
Hugging Face.
Hugging Face.
So yeah, I'll see which will be most applicable for this situation. Then proceed here. Yeah, do you have any other points here?
Oh, I don't have much to say because since this is a project and so more questions will come after you you do some
Yeah,
project
let's
and
start.
you show
Yeah,
something. Yeah. So I don't know nothing more to say about this.
then I
So
think we can end here.
okay.